In problem number 1, the key in this paragraph is the wording generally increased, which means that the data should generally be going up from left to right. And here are some examples. In real life, the data is almost never going to make a perfect straight line like this. It's going to be something more like this or this, where you can still draw a line through the middle and see that it is generally going up, even though it's not in a perfectly straight line. So this is what the scatter plot should look like, at least something like this, if it shows that it generally increases. So if we compare those examples to the scatter plot that we have here in the problem, if I draw a straight line, it doesn't show that same upward pattern. This scatter plot is really kind of all over the place and doesn't show a general increase the way that it needs to show. So for that reason, we're not going to say A or B because it definitely does not show an increase. So remember in math, the word we use for an increase is a positive slope. Each of these lines is going up in a positive direction. And so because the scatter plot that we have here is not, is not moving in a positive direction, then we need to say option D is the correct option because the scatter plot does not indicate a positive relationship, which is what you would need for it to be an increase. So you should have option D. In problem number 2, the word variance means how spread out is your data. So it's asking which one is the most spread out. So in option A, you can see that they are just spread out by 1 in between each data value. Option B is not spread out at all, so this one has no variance whatsoever. Option C is spread out by 10, and option D is spread out by 1. So even though D has the biggest numbers, the one that is the most spread out is going to be the one that is spread out by 10. So that means you should have option C for your correct answer because option C is the one with the most spread, also known in math terms as variance. In problem number 3, it asks us to analyze the part of the graph that shows voters between 30 and 49 years old. So I'm going to focus on this part of the chart. And it says, what is the probability that the voter lives in the East District? So these are the number of voters from the East District. And we need to find the probability of those in the East out of the total. So we need to divide 220 by 290 because it is the number of voters from the East out of the total number of voters, which was 290. And we can use our handy Desmos calculator to help us figure that out. So I typed it into Desmos and I got this decimal right here. And so which one of these is the closest to 0.758? Well, that is going to be option D. So D is the closest probability to the number of voters from the East out of the total. Problem number 4 is pretty tricky, so I'm going to take my time with this one. First of all, the teacher told the student that he answered 70% of the questions correctly, but the problem asks about the questions he did not answer correctly. So we'll take 100% and subtract the 70% that he got correct, and that tells us that he got 30% of them incorrect. So that means that 30% of the total number of questions on the test will equal the number that he got incorrect. So we can turn this into an equation, and first I know that I need to change this I need to change this percent into a decimal by moving the decimal 2 places to the left. So this becomes 0.30. Remember that of is a code word for multiplication, and we don't know what the total number is, so I'm just going to use the variable x, and I'm going to use my multiple choice answers starting with option A. So I'm going to start by trying to solve the equation for option A to see whether or not I get a number that makes sense. So if he got 30% of the total wrong, could it equal 22? So in order to solve for x, we know that the inverse of this multiplication is division. So I'm going to divide both sides by 0.30 to see what value I get for x to isolate that variable. I'm going to use my trusty Desmos calculator to do 22 divided by 30. And when I do, I see that I get this wacky decimal right here, 73.333. Well, you can't have 73.33 questions on a test. So that answer doesn't make sense. So we know that A is not going to be the correct answer. So now I'm going to try the same strategy with option B in the multiple choice, and I'm going to solve the equation 30% of the total equals 23 and see if I can get a whole number for this one. So I'm going to divide both sides by 0.30 in order to cancel and solve for x to isolate it. Again, I use my handy Desmos calculator, and if 23 were the right answer, that would mean that the total number of questions on the test is 76.6666. Well, that answer doesn't make sense either because you can't have 76.666 questions on a test. So option B is not correct either. Now I'm going to try the same thing using option C. I'm going to divide both sides by 0.30 again to cancel and isolate my x. I used my handy Desmos calculator again, and now for the total number of questions on the test, I actually got a whole number. So it's possible that there could have been 80 questions on the test. Geez, who wants to take an 80-question test, man? And so because we got an answer that makes sense, that means that C is the correct answer because I can take 30% of 80 and get 24. In problem number 5, it says the ratio of boys to girls is 4 to 5. That means for every 4 boys, there are 5 girls. So that means each group must consist of 9 kids because for every group of 4 boys, you have 5 girls. And I added them together to get 9 total because the question is asking about the total number of students. So what if I had 2 groups of kids? Well, that means that I would have 18 total. But that doesn't match any of my multiple choice answers. So if I add another group, now I've got 27 students total. And there we go. That 27 matches this multiple choice answer. So this is the correct answer for what could be the total number of students, because it's the only number that you can get by putting together groups of 9. Number 6 is yet another percent problem. As you can see, those are all over the cert. And I've set up another equation. So 65% of a number. We don't know what that number is, so I'm going to use X. And it says is 234. So I'm going to convert that percent into a decimal so that by moving it over to places, so I've got the equation 0.65 times my variable that I don't know equals 234. Just like I did in the last problem, I'm going to isolate that X by doing the inverse of this multiplication, which is division. And I am going to divide to cancel out that 0.65. And I need to remember to divide on both sides. I used my handy Desmos calculator, and I can see that X is going to be equal to 360. So that missing number that I was trying to find is 360. So now that I know that that number is 360, I'm ready to find 120% of that number. So now I'm going to do 120% of 360. And the calculator has another super cool feature where you can actually just put the percent right in there and it'll automatically do percent of. So as we can see here, 120% of 360 is 432. So you should have option C. For problem number 7, it says that Jillian wants to add a number to this data set so that the mean and the median are equal to each other. So what I did is I just typed that list into Desmos. Remember how to make a list in Desmos. And I went through and I tried each multiple choice answer where I added that answer in there to see whether or not I got the same mean and median. So as you can see, if I added 12 to the data set, my mean and my median are not the same. So option A is not the correct answer. Then I tried B and C and didn't get that either. But now I see when I put my list in there and I add multiple choice answer D, I do in fact get a mean and a median that are equal. So that means that the answer should be D. Finally, number 8 asks, out of our histogram, which number could be the median number of pages? So I'm going to zoom in here for a second and remind you how to read the histogram. So because this bar lines up with the 2, that means that there were 2 magazines that had between 10 and 20 pages. Then because this bar comes up to the 4, we know there were 4 magazines that fell there. You see where we're going with this. There were 7 that fell here, 6, 2, 1, and 1. So if I add all of those together, I've got a list here in the histogram of 23 magazines. So if I think about where the median, where the middle of 23 magazines would be, I would have 12 numbers in the front. No, I wouldn't. I would have 11 numbers in the front. I would have 11 numbers in the back. And then that one median would be right there in between because 11 plus 11 is 22 plus 1 is 23. So I just need to figure out where, so basically the median is going to be the 12th number that is represented in my histogram. So I've got 2 here, plus 4 is 6, plus 7 is 13. So that means that the 12th number has to be right here in this area, which means it has to be in between 30 and 40, which means that the only one it could be on this out of our list of multiple choice answers is 38. So the answer for number 8 should be B.